All right, grade 9s, welcome to Math 9 Virtual Classroom. I know you're all as excited as I am. We're just going to pick up where we left off in 1.1. We talked about line symmetry, so splitting an object in half, kind of using our mirrors and mirrors to kind of figure out if an object has line symmetry, either vertical or horizontal or diagonal or oblique. And in this section, we're going to look at a different type of symmetry, rotational symmetry. So an object doesn't necessarily have to be flipped in half to have symmetry. It could also be rotated to have symmetry. And we'll look at a few examples where that's the case. So a couple of terms that we need to know is the center of rotation and rotational symmetry. So you can read through those. Center of rotation, usually when we're doing rotational symmetry, we're rotating it around the center of the shape. And basically an object has symmetry if, when you rotate it, it can get back to its original shape, okay, before you rotate it all the way around. So I'll take this as an example here, and if I start rotating, you've got the purple part of the shape here, and before I get to the start of it, I've got the exact same shape back, once, twice, and actually 3 times before I get to the end. So this one has actually, we call it the order of 3. So it has a rotational symmetry of order 3. And so we'll talk more about that in the example. So basically, if I can rotate a shape, then it has rotational symmetry if it gives me the exact same shape. Okay? So we'll look at a few examples here. In example 1, the Jamaican flag here. For each shape, what are the order of rotation and the angle of rotation? So we'll touch on both of those. So the order of rotation just refers to how many times you can get the same shape back when you rotate it all the way around 360 degrees. So in this case, with this flag, you can't tell the difference if you flip it upside down, right? You can keep rotating. Now this is the exact same flag, and then once I get back to the original. So basically what I have is that it rotated and got me the same shape twice. So the order would be 2 for that shape. Okay. The angle refers to how many degrees do I have to turn it in order for me to get back to my original shape. So it's actually a really simple formula to do. We basically take the full 360 degree turn and we divide it by the order. So I got the same shape back twice. So if I divide it by 2, this shape would have an angle of rotation of 180 degrees. Right? It's a little bit of common sense too for some of them. Right, for this one, it kind of makes sense. We know we flipped it perfectly around, so we know that's 180 degrees. We know it's kind of like flip 90, another 90 is 180. So a little bit of common sense for some of them, but some of them are a little bit trickier. Okay, so the order versus the angle of rotation. Okay, some shapes maybe don't work, like this one. I believe if you rotated this, you could flip it, but it's going to be a mirror image, right? That's not the same image. This is the mirror image. It doesn't get back to its original shape until the very end, where it gets back to exactly where it started. So we'd say the order is actually just 1. So it really doesn't have rotational symmetry, in other words. Okay, so an order of 1 or 360 degrees means it doesn't actually have symmetry. Okay, this one, pentagon. You can see that if you started rotating this thing once, twice, 3 times, 4 times, 5 times, and you're back to the original shape. So you were able to rotate it 5 times, so the order was 5. And so to figure out the angle, we would take 360 degrees and we would divide it by 5. Is that 72 degrees? I better check. Just to make sure. 360 divided by 5, yeah. So 72 degrees would be the angle of rotation. Okay, sometimes shapes have line symmetry, sometimes they have rotational symmetry. They could have neither, they could have both. This one, by the way, doesn't have rotational, but if we go back to 1.1, it would have line symmetry across it, right? Okay, show you a couple more examples here. This is like the Métis symbol, I think, or something. It's kind of like an infinity symbol. You get back to the original shape once, twice. So it's just like the Jamaican flag. It has order of 2, and then angle of 180 degrees again. 360 divided by 2. Okay, this one here, I can't get back to my original shape. I'm just rotating it. I never get back to the original shape until I go all the way around. So that one doesn't work. This one, I could get back to my original shape here. Once, twice, and 3 times. Okay, so that one has order of 3, and then 360 divided by 3 gives you 120 degrees for the angle. Okay, so that's really all there is to it for order of symmetry. Some of these in this last example here we'll go through where we look at both. Okay, what type of symmetry does each figure demonstrate? So we'll look first at the line symmetry for each of these shapes, and then we'll look at the rotational symmetry. This one is kind of tricky. You might think without these arrows, it would actually have line symmetry down the middle, but since there's an arrow, we have to think, is it actually mirroring itself or not? And any one of these places, it doesn't actually mirror itself because of these arrows are pointed in a certain way. So it actually doesn't have line symmetry. Okay. The second one, you could find symmetry if you did that perfectly. You'd find it there. This one, line symmetry, both vertical and horizontal. You might think it's oblique, but with that diamond in the middle, it's actually not going to perfectly mirror, right? If I would mirror this, it would kind of pop out like that. So it's not quite, so it's just 2 lines of symmetry. So lines of symmetry, hopefully pretty straightforward. This one doesn't have it. This one has 2. This one just has the 1. Okay. These exact same shapes also could have rotational symmetry, so we can just look for that. Of course, you don't have the luxury of actually twisting a shape, but you can kind of play around with your book or try to visualize it as best as you can. But I can rotate it here, it's back to the original shape here, and then finally again. So this one would have order of 3, and then 360 divided by 3. This one also has 120 degree angle of rotation. This one, probably notice right away, you're not going to get back to its original shape until you do the full 360, so it just would have order of symmetry of 1, or you could say NA doesn't actually have rotational symmetry. And then this last one, not back at my original. Now I'm at my original shape again after half a turn, and then another half a turn and I'm back. So order, angle of symmetry. Okay, so any questions? No? Okay, perfect. Awesome. One more example. If we're looking, again, we can look for line symmetry or rotational symmetry. I think I've got these shapes ready to go for rotational symmetry. So I can actually pull them back to its original, and then one more and it's back to its original. So again, that one has order of 2. Okay. And again, 360 divided by 2 is 180 degrees. The next one here also, I believe, has rotational. We have to pay attention here to exactly what the shape looks like. Some of them are a little bit tricky. Back to its original once, twice, 3 times, and 4 times. Okay, so it has order of 4, and 360 divided by 4 is 90 degrees for the angle of rotation. Okay, and we can also check for line rotation. This one, if I draw a line and that was perfectly through, it has both vertical and horizontal symmetry. This one I do have to be careful. You might think it possibly is, but if I draw that line, this should be just as far out as this. It's not actually symmetrical for line symmetry. So this one doesn't have the line symmetry. This one does. Okay? Man, that's just a quiet class this morning. That's awesome. You guys are so well behaved. Really appreciate that. So a few questions for you to practice. Page 21, I think on Google Classroom, I picked a few of those questions for you to do.